Okay, a quick tutorial on factoring a difference of squares. So first of all, you have to recognize what a difference of squares is. And a difference of squares is always in the form of some perfect square subtracting some other perfect square. The difference means subtract. So this does not work if it's a squared plus b squared. It only works if it's a squared minus b squared. If I find something that I need to factor that has those two terms that are perfect squares and they're subtracting, then the factoring is easy. I take the square root of the first and put it at the start of each bracket, the square root of the last, put it at the end of each bracket, and I alternate my plus and minus sign. And that's it. So let's do an example. First of all, let's say I was given 9x squared minus 25. I have two terms, so I can't do simple trinomial, I can't do complex trinomial. It's not a perfect square trinomial, it's no trinomial at all. So what I want to look for next is it a perfect square, or is it a difference of squares? Is the first term a perfect square? And 9 is a perfect square. Is the last term a perfect square? Yes, 25 is a perfect square. Is the middle sign negative? Yes. And so now this fits my pattern of a perfect square subtracting another perfect square. So once it's in that form, I'm going to set up two brackets, and I'm going to put the square root of the first term at the start of each bracket, and the square root of the last term at the end of each bracket, and then I'm just going to alternate my plus and my minus sign. I can check to see if this is true by expanding this out. So if I have 3x plus 5, 3x minus 5, and I want to expand that out, I multiply the first two terms together of each bracket, so that's going to be 9x squared. Then 3x times negative 5 is going to be negative 15x. 5x times 3x is going to be positive 15x. And 5 times negative 5 is going to be negative 25. And when I simplify that, 9x squared, this negative 15x and positive 15x is going to equal 0. It's going to equal 0. And it's going to eliminate it. So I've just got 9x squared minus 25. And that's going to happen every time when you have a difference of squares. Those middle terms eliminate each other out. Okay, let's do another example just to make sure we're on the right track. Okay, so let's say we have 64m squared subtract 1. So first of all, again, I look to see if both the first and last term are perfect squares. Yes, 64 is a perfect square. 8 times 8 is 64. 1 is also a perfect square because 1 times 1 is 1. So, and I have a negative sign there, a subtract sign. So I know this, I can factor this using difference of squares. And when I factor using difference of squares, I take the square root of 64, which is 8, and the square root of m squared is m. So I put that at the start of each bracket. I put the square root of 1 at the end of each bracket, which is still just 1. And I alternate my plus and minus sign. Notice it doesn't matter which sign you put first as long as you just have one of each. Okay, let's try one more example. Let's say you have 81 x to the fourth minus 16. Let's do y to the fourth. Okay, now x to the fourth we can take the square root of x to the fourth. So what that's going to leave us with is the square root of 81 at the start of each bracket, which is 9, and the x to the fourth, which is going to be x squared and x squared. Let's take the square root of 16, put it at the end of each bracket, which is 4, and the square root of y to the fourth, which is y squared, y squared. And then we're going to alternate our plus and our minus sign. Now remember, when we're done every single factoring question, we look inside our brackets to see if there's any more factoring we can do. So let's take a look at inside my first bracket here. If I take a look inside my first bracket, is there a common factor? No. Is there any other types of factoring I can do? Doesn't look like it. Let's take a look inside our second bracket. So in my second bracket, I've got 9x squared minus 1y squared. Hey, hold on a second. 9 is a perfect square, 1 is a perfect square, I can do difference of squares again. So what's going to happen is this first bracket stays the same because I can't do any more factoring there. But my second bracket, I can do difference of squares for the second time. The 9x squared gets written twice, or the square root of 9x gets written at the start of each bracket, so 3x and 3x. Square root of y squared gets written at the end, which is just y. And then I alternate my plus and my minus sign. Now I look at my brackets. If there's any more factoring I can do, no more. I cannot do difference of squares here because this isn't a difference. It's a sum. So then I'm all done.